there's a photograph that shouldn't exist. Taken by the most powerful telescope ever built, aimed at a patch of sky no bigger than a grain of sand held at arm's length. The James Webb Space Telescope pointed into what we assumed was empty darkness, into the cosmic abyss where nothing should be. What it captured has unraveled a century of certainty. These galaxies are impossible. Too big, too bright, too soon. They glow with the light of billions of stars, fully formed and majestic, existing in an era when the universe was supposed to be dark and primitive. And they're forcing us to confront a disturbing truth. Most of the universe is slipping away from us forever. For thousands of years, we looked up and wondered, how far does it go? Where does the darkness end? In 1929, Edwin Hubble gave us the answer we didn't want to hear. The universe isn't static. It's expanding. Every galaxy is racing away from every other galaxy, like dots on an inflating balloon. The farther away a galaxy is, the faster it recedes into the void. We traced it backward through time. 13.8 billion years ago, everything began. One moment, one explosion, the Big Bang. All of space, all of time, all of matter compressed into a point smaller than an atom, then erupting outward in the most violent event in cosmic history. Simple math, right? If the universe is 13.8 billion years old and light travels at a fixed speed, 300,000 kilometers per second, then the observable universe should be 27.6 billion light-years across. Light from the beginning, traveling toward us for the entire age of the universe. Except it's not. It's 93 billion light-years across. How does a 13.8 billion-year-old universe stretch 93 billion light-years? How did space itself travel faster than light? The answer lies in the first fractions of a second after the Big Bang. Cosmic inflation. In less time than it takes light to cross an atom, the universe doubled in size more than 60 times. Space itself expanded faster than anything within it could travel, not breaking the speed of light, but stretching the fabric between objects so violently that distant regions shot beyond each other's reach. The universe didn't just grow. It exploded outward in a way that defies our everyday physics, creating distances that light will never cross. And that's just the beginning of what we got wrong. Every photon carries a story. Every particle of light is a messenger from the past. You know the Doppler effect, that shift in pitch as an ambulance screams past you. Sound waves compress as it approaches, stretch as it leaves. The siren rises, then falls. Light does the same thing, but across cosmic distances. When a galaxy moves away from us, its light stretches. Blue becomes red. We call it redshift, and it's our cosmic clock, our way of measuring time itself across the universe. The farther away something is, the faster it's moving away, the more its light shifts toward red. A galaxy with a redshift of 1 is 7.7 billion light-years away. Redshift 2? 10.3 billion. Each increment takes us deeper into the past, closer to the beginning. But the James Webb can see redshifts beyond 13. Galaxies from when the universe was barely 300 million years old, just 2% of its current age. An infant cosmos. We expected to see infant galaxies. Dim, small, chaotic. Clouds of gas barely beginning to condense. The cosmic equivalent of newborns still learning to crawl. Instead, we found giants. Galaxies that shouldn't exist for another billion years. Massive spiral structures spanning hundreds of thousands of light-years. Fully formed disks rotating with mathematical precision. Stars by the billions, already burning, already dying, already forging the heavy elements that make worlds possible. One researcher put it simply, These galaxies are too big, too bright, and too structured for their age. It's like finding a fully grown adult in a nursery. Our models say it takes time to build a galaxy. You need dark matter to create gravitational wells. You need gas to collapse under its own weight. You need generations of stars to live and die, forging heavy elements. You need billions of years of cosmic evolution. But these galaxies skipped the line. They assembled impossibly fast, as if the early universe had access to resources or physics we don't understand. The standard model of cosmology, tested and refined for decades, cannot explain what we're seeing. Here's the nightmare that keeps cosmologists awake at night. Right now, we exist inside a sphere, the observable universe, 93 billion light-years across, a bubble of visibility in an infinite ocean. Everything we can theoretically see, everything we can study, everything we can know about reality exists within this boundary. But beyond that edge, there's more, much more, and it's disappearing. In 1998, two teams of astronomers made a chilling discovery. They were studying distant supernovae, stellar explosions so bright they can outshine entire galaxies. What they found defied everything. The universe isn't just expanding, it's accelerating. Something is pushing space apart, faster and faster. An invisible force permeating every cubic centimeter of emptiness. We call it dark energy. And it makes up 68% of everything that exists. Here's what that means. Right now, there are galaxies we can see, barely, at the edge of our cosmic horizon. Ancient islands of light, their photons traveling for over 13 billion years to reach our telescopes, each one a message from the deep past. But next year, some of those galaxies will cross a threshold. The space between us and them will be expanding faster than their light can travel toward us. The final photons already on their way will arrive, and then nothing. Silence. Darkness. And we will never see them again. Every second, 20,000 stars cross that boundary. Every day, entire galaxies slip into permanent darkness, severed from our observable universe forever. In 1 trillion years, a civilization arising in the Milky Way will look out and see almost nothing. A few local galaxies, gravitationally bound to our own. Empty blackness beyond. No evidence of the Big Bang. No distant galaxies to study. No redshift to measure. No cosmic microwave background to map. They'll conclude they live in a small, static, eternal universe, and they'll have no way to know they're wrong. All the evidence will have vanished beyond the horizon, racing away faster than light itself. We are lucky. We live in the narrow window of cosmic history where the universe reveals its secrets. But the window is closing, second by second, photon by photon. There's a war happening right now, across every galaxy, every cluster, every superstructure in space. And the battlefield is completely invisible to us. In the 1970s, astronomer Vera Rubin discovered something impossible. Galaxies were spinning too fast. The outer stars, tracing vast orbits around galactic centers, should be flung into intergalactic space by centrifugal force. But they weren't. They held together, spinning in perfect formation. Something invisible was holding them together. Something with gravity, but no light, no heat, no electromagnetic signature of any kind. 5 times more massive than all the visible matter in the universe combined. Dark matter. 27% of the universe. It forms the scaffolding of reality. Invisible threads connecting every galaxy, creating cosmic superhighways of structure. Filaments of dark matter stretching across billions of light years, guiding the formation of everything we see. Without it, Galaxies would never have formed. Stars would never have ignited. Planets would never have coalesced. We wouldn't exist. But dark energy wants the opposite. It wants to tear everything apart. Dark matter pulls inward, trying to collapse structures under gravity. Dark energy pushes outward, accelerating expansion, driving space itself to grow. For billions of years, dark matter was winning. Galaxies formed. Clusters assembled. The cosmic web took shape, a magnificent tapestry of light and structure. But 4 billion years ago, the balance shifted. Dark energy began to dominate. Now, the largest structures in the universe are being slowly torn apart. Galaxy clusters are drifting away from each other, their gravitational bonds weakening. The cosmic web is fraying at the edges, and the acceleration is increasing with every passing moment. In 100 billion years, galaxy clusters will be completely isolated, islands of light in an ocean of expanding void, separated by distances that light will never cross. And still, the expansion will continue, relentless and unstoppable, until every galaxy is alone. Every star burns out. Every black hole evaporates into radiation, and the universe becomes a cold, dark, empty expanse, stretched to infinity. This is the fate we've calculated, not with philosophy or speculation, but with mathematics, observation, and the light from those impossible galaxies that shouldn't exist. The James Webb Space Telescope wasn't built to confirm what we knew. It was built to challenge us, to push the boundaries of understanding, to show us what we missed. And it has delivered. Galaxies that shouldn't exist, glowing in epochs that should be dark. Light from times we thought were silent, revealing structures that defy our models. Questions that dismantle decades of certainty, forcing us to reconsider everything we thought we understood about cosmic origins. The universe is not what we thought. It's stranger, faster, more violent in its birth, and more lonely in its fate, more complex in its structure, and more mysterious in its composition. Every night, the observable universe shrinks, not because space is disappearing, but because it's racing away from us faster than light can catch up. Galaxies vanish beyond the horizon. Stars cross the boundary into permanent darkness. The cosmic web stretches and tears. But here, now, in this brief cosmic moment, we can still see. We can still measure the redshift of ancient galaxies, still question the nature of dark matter and dark energy, still search for answers in the light of stars that may no longer exist, their photons carrying messages across billions of years. The universe is vast, ancient, and mostly beyond our reach. 95% of it is invisible to us, dark matter and dark energy whose nature remains unknown. Most galaxies will eventually slip beyond our cosmic horizon, severed from our view forever. But for now, just for now, it's still revealing its secrets. Those impossible galaxies shine in our telescopes. The cosmic microwave background still whispers the story of creation. The universe still lets us witness its grandeur. And we're here to witness them, to ask the questions that matter, to search for truth in the light of distant stars.